All right, so let's move on. There's the demonstrations. Of course, you can work ahead or behind me, but I do want to cover the important things at demonstrations. Now, 353 is really important, but before we go there, I want to do 354 and 355 to set it up. So we'll start at winning an auction here, 354. So I can move this to the side and do it here. So I start back here where I can see the contracts, and the contract this time is the auction contract, which I've got here. And I'm going to paste in new code because I might have a fixed auction contract in there. I'm not sure. So let me do this. So I can delete the old stuff and put in the fresh stuff. All right. So there is my auction contract. Now the point here is people can bid for something, and when someone bids, it then checks to see if the amount they bid is greater than the highest bid. And if it is, then they refund the old leader, and if that fails, then cancel the whole transaction. That's this require. If this fails, it will stop the whole contract at this point and not continue the transaction. But if the previous leader can get a refund, then I change the current leader to the new person, and that becomes the highest bid. And it accepts money. This is payable. So you bid, and it takes your money. And when someone bids higher, it returns your money and goes to the next person. So that is the actual auction contract itself. And we have an attacker here as well, which would, of course, be deployed by a separate person, but we're just combining them here for simplicity. And the point is the attacker simply refused to accept refunds. So you cannot give the money back, and that means nobody else can ever become the highest bidder. And so what you do here is it has a fallback function. Now, this is a weird property of Solidity, which I think they eventually changed in later versions. But if you don't define a ready to receive money, a receive function, it will use this fallback function for any function. When you send money to the contract, it will go to the fallback function. And what I do here is I refuse to receive money. If you try to send me money, I just call revert and cancel the whole contract. So nobody can ever send me any money in this contract. And that means I will never lose the auction. So once you've got that in there, you compile it. Compile auction, and all right, and then we're going to deploy it. Now, we've got old contracts here from a previous challenge, so the trick is just change JavaScript VM London to Berlin, and then back to London, and that will give you a fresh simulated blockchain with clean 100 ethers everywhere and all the old contracts removed. So now we can deploy this contract. And oh, that's right. I deployed the wrong one. You can't deploy the attacker first. First, you have to deploy the auction. And the auction doesn't have any parameters, and you deploy it. Now, the attacker needs to have the address of the contract to attack. So now that I've deployed the auction contract, I take that address, and I use that to deploy the attacker contract. It needs that address. And now I can deploy that one as well, and it will succeed. Now I have two contracts. So the first thing is to just use the auction contract the way it should be. So expand it and go down here, and now you can bid and see who the current leader and the highest bid are. So let's take the first account, which is here, and bid 1 ether. All right, and bid. And so that worked, and my balance fell down to 98.9 because I spent an ether. And if I check here, the current, okay, now my contract address, my account address is 5B3. So the current leader is 5B3. And the highest bid is 1 times 10 to the 18, 1 ether. All right. Now I go to the second account and try bidding 2 ethers. Go here and bid 2 ether. And this is now AB8. So I bid, and it worked. So now it's AB8 is the leader with 2 ether. and that money got refunded to number one. Number one is back up to almost 100 ether because it got back the 1 ether. All it had to do is pay some gas here. So it's working as expected. Now I'm going to cheat. So I go to account number 3 and bid 3 ether and use the attacker contract and win. And that worked. So now the third account is 5C6, and the current leader is DB8, which is my attacker contract. The contract itself is the winner. It's not the contract that up there. It's the contract here. But the contract is owned by the attacker, so they can get the money out of it. So this is now the leader with 3. And now if the first person tries to bid 4, it should fail. So this person tries to bid 4. And it fails. The contract has been reverted. You did not get to bid 4. The current leader is still the same, and the highest bid is still 3. So this malicious contract has frozen the bidding, and it's always going to win. So this is a logic flaw that you can see in action. All right.